In this session, we will be looking at simple data set and how to carry out regression for this simple data set. So over here we have what was an excerpt of our bikes data set, and we have the customer age and revenue. Now, the scenario is that revenue is our target variable, dependent variable, and customer age is our independent variable. And we want to fit a simple linear regression model to this data set and see what we get. So in Excel, we can use the data analysis toolpack to be able to run a regression analysis. You could go to the file or the tools if you're using the Mac and check for the Excel add-ins. But if you're using the Windows operating system, you can use file options and then select Excel add-ins. These add-ins then give you the option for having the analysis toolpack. Select that. If it is not activated, have it activated and click OK. Now your menu will not just have the home, insert, draw, and so on. It will now have a data portion. This data portion, when you scroll across to the bottom right-hand side, or the top right-hand side rather, you should find a data analysis tool. Click that and you will find different statistical tests, one of which we're interested in, which is regression. So we click regression and we form the regression test within this inbox that it generates. What is the Y and what is the X? Recall that within our analysis, we have the two variables. We refer to the Y as the dependent variable, in this case, the revenue, and the input X range, or X, would be the independent variable. So I'll go ahead and select the revenue data. So moving along and selecting that as my Y, and then selecting the customer edge as my X. Okay, scrolling down, selecting everything, including the headers. I then in the dialog box inform that I have my label selected. If you hadn't had the label selected, do not have this activated. I also select for the default confidence level. I want my output result to be put in a new worksheet that is called Simple Linear Regression. And then I also want to generate some metrics, like for instance, the residues and the residue plots and a line fit plot, because I can then fit the equation of best fit onto that. Okay, I click OK. And this is what my output now shows. I have generated a summary output. I will increase that zoom. And this summary output has all sorts of information, including aspects on the multiple R, aspects on the R squared, or the performance of the model. In this case, it is a bit low. Okay. We also have the standard error and the observations that we worked with. We had only 35 samples. There is also the intercept that we're interested in, and those residuals as the model was performing. The model also generates for us a line of best fit. This line of best fit is showing us how the model is fitting to this data, and it is also showing us the original revenue and the predicted revenue as a result of the effect of customer age. We can select anywhere within this graph to add a trend line. And so we can do this. Once you select this portion, you're going to have your chart design activated. And on the top left-hand corner, you will have add chart element. So click that and add a trend line. So there are different options for trend lines. Click more trend line options, or if in your case it displays all the options, the one we are selecting for the linear regression is the linear trend line, okay? And at the bottom, there are more options of what results you can get. We can display the equation onto the trend line, and we can also display the R-squared value on the chart. That way, this is something you can reproduce in your work and showing the performance of your model, okay? So this relationship looks like it is quite a little linear, but not so much linear, almost linear, and it may require a different tech, okay, of another type of linear regressor. So in which case, if it is not a very strong linear regression or linear relationship, that we would have noticed by looking even at the multiple R, okay? This multiple R is a correlation coefficient that would range anywhere from -1 to +1. And it lets us know, it is letting us know about the correlation between the two variables, the customer age and the revenue. And in our case, it is a value of 0.286, which is quite low. So this is a weak relationship. It is not a strong linear relationship. Ergo, based on the assumptions of the simple linear regressor, this is a relationship that does not fit the assumptions or the requirements for a simple linear regressor model to be used. So in that case, we would have to use a polynomial regressor. So after you've calculated your regressor outputs, in Excel, rather than using a simple or a linear trend line, you can instead add the polynomial trend line. So I'm going to select over here. And again, go back to the chart design on the left top hand corner, select trend lines and choose more options. In the options on the right-hand side, I am going to select polynomial, and then I am going to have the display of that output for polynomial so that I can have that result. So it is fitted now to a curve rather than to a linear graph, okay, or a linear line. So we now have a polynomial regressor, and it has a different type of equation, and it also has a different R-squared value. Just moving it a bit here so that we can see it a little clearer. Okay, so that's the R-squared value in terms of its performance, and this is what it looks like in terms of that equation of the curve. So if herein, you can now fit in your Y values and your X values, rather, which are your customer age, to then make a prediction of what your Y value should be.